So a very good afternoon to everyone, and today we are going to study the topic 1:60 rule. Initially we'll see the definition using this diagram, then we'll proceed towards the question that how does this work? Why does this formula work? And in the end we'll see the applications, first in general exam questions and second in real life, how we can use the formula to get the required values. So let's begin with the definition. What is the definition of 1:60 rule? It says if our track error is 1 degree, means our actual track is 1 degree away from the required track, and then when we travel 60 nautical miles away from the initial point, we will be 1 nautical mile away from the required track. That's the definition of 1:60 rule. But why does this work? Why it's 60, not 70, not 80? Why so? So let's see. This formula, theta is equals to S by R, and theta is in radians. Please make sure of that. It's not degrees. It will be wrong if we write here degrees. This formula was taught in class 11th, if I remember correct, and this is a very well derived formula, very highly used in mathematics. And why this formula we are using to get the altitudes and track errors and whatever we have, because it is the ratio of arc length and the radius. What's S? It's the arc length, R is the radius, and whatever is the fraction, the value of the fraction, that is the angle subtended at the center of the circle. Okay, fine. But what is this? The formula that we use in air navigation is theta equals to S by R into 60. From where is it coming from? So, because 1 radian is equals to 57.29 degrees, roughly rounding off 60 degrees, that is why we are multiplying 60 here. Simplify it a bit more. Okay, so let's see. Let's assume the radius is 50 centimeter and also the arc length is 50 centimeters. What will happen then? We'll put the value of S and R. S equals to 50 centimeters, R equals to 50. Both cancel each other. Value is equals to 1. Theta is equals to 1 radian whenever the arc length is equal to the radius. So if we wanted to convert exactly this into degrees, that's what we use in aviation. For everything we use degrees. So we'll simply multiply here by 60, and for the same question we'll get the angle made at the center will be equals to approximately 60 degrees, and that's why to get the answer directly into degrees we use this S by R into 60. But there's a trick to it. We cannot use it for every angle. So what's the restriction? The maximum angle that for which we can use this formula is 20 degrees. Let's see why. You see the diagram here? What is this? If we enlarge the part that's drawn in the circle, it will look a bit like this. So how to understand this? We take smaller angles only, because for smaller angles the straight length that we are creating is almost equal, coinciding with the curved path of the circle. But with larger lengths, the angle that's subtended will not remain equal. Let's see. Let's take this part and pull it like this into the curved path. That is the path of the arc of the circle. This is the angle made by the line, and if we pull it like this in a circle, a higher angle will be made. So the error will also cause this formula to malfunction. That is why we can only use this formula up to 20 degrees. Now, the applications. How do we use it? Where does this come into use? So very generally in climb and descent questions, also when we have to calculate the track error, how much are we going wrong from the required track, we use this. Let's see a quick example. 3 degree, that's the glide path. That's also the standard glide path that is mostly used in aviation when the aircraft is continuing its descent. So we have the 3-degree glide path angle. We are 10 nautical mile away from the runway. Our altimeter failed. Now what will we do? We need to do something now. We are pilots. So we will use this formula, theta equals to s by r into 60. Let's quickly do this. So theta, what's it? 3 degrees. Let's write it down. S, we do not know the s. That's what we need to find. So we'll write it s. R, that's the radius. We'll take it as 10 nautical miles and into 60. So the value of s is coming 0.5. 0.5 what? 0.5 nautical miles. Why nautical miles? Because the first value was also in nautical miles. So our altitude is 0.5 nautical miles above the ground. But whenever talking about altitudes, we as pilots never speak it in nautical miles, always feet. Quickly converting it into feet, 1 nautical mile 6080 feet, half a nautical mile 3040 feet. So we'll say our altitude is 3040 feet. Again, another question. This time we are flying away from a VOR DME, and after traveling 15 nautical miles, we find we are on another radial. Earlier we were traveling on 090 radial. Now we found out from our VOR indicator that we are on 080. Now what? We need to calculate how much far away we are from the required track. Again, same formula. This time theta is the value that we need to, this time s is the value we need to find, just like above. From where we'll get the theta? The difference in radials. First radial 090, second 080. If we take it as degrees, gap of 10 degrees is there. The r is 15 nautical miles. We need to find s. We have 60. Let's just put the values. S equals to 10 by 4. Again, 10 by 4 what? Nautical miles, because we put it in nautical miles. So what's 10 by 4? 2.5. We are 2.5 nautical miles away from the VOR radial we were supposed to fly on. That's the basic questions. Please note it down. Then we'll also discuss some very important and complex questions that come from this 1:60 rule. So, first question. After flying for 300 nautical miles, an aircraft finds itself 30 nautical miles away from the required track. Now it has 600 nautical miles more to go to reach the destination. Find out the correction angle. So, what's the first step? Punch in all the values and find the angle and put the correction angle? Nope, that's not it. The first step, whenever you get a question like this, draw the diagram. Why? Because this question looks very innocent, but it is the type of question that's responsible for the maximum errors that you do even after knowing the question. First of all, draw the diagram, know the situation you are in, know the requirement the question wants from you, then proceed. Also, write down the formula we are going to use in this question always. Even if you know the formula very well, still write it down. So let's see what we need to do now. We are flying here. Our heading has changed, our track has changed, probably due to crosswinds. Now our requirement is to reach the destination, the main requirement that we need to do. What will we do now? Some correction angle. Why? Because if we do not put that correction angle, we will never reach the destination. We will reach somewhere else. And what is the correction angle? Is it equal to this angle? Equal to this angle? Which angle? Let's see. First, let's calculate all the angles that we do not have yet using this formula, which is this angle and this. Then we will see how we can use those two to find out the correction angle required. So angle 1 S 30 nautical miles. Again, one more thing, a lot of students and sometimes me also, whenever I face the question like this, I forgot which one was supposed to be S. Was it this or was it this? Just a trick to remember, in the formula you see now, S is right in front of theta, the angle. Similarly, whatever is the line right in front of the angle, that will be your S. Let's put it. Theta equals to 6 degrees. Now what? We got this equals to 6 degrees. Now let's calculate the second angle. Again, same process. Let's write it theta 2. Degrees. This angle is equals to 3 degrees. Now what? We got this, we got this. Now what are we going to do? Calculate these all angles. We can directly put the correction angle as 6 plus 3, 9 degree. Let's first write it, then we'll see. Why? Why did I just add them up and put it there as correction angle? How I am too sure that that is it? Because if you remember the junior classes in mathematics, it says the exterior angle of a triangle is equal to the sum of two opposite interior angles. This is the exterior angle, 9 degrees. That's how we found it. The most common mistakes that can be done in this question, putting opposite value of S and R, and the second, putting 6 degrees as the correction angle. No, the correction angle will be 6 plus 3y. If we turn 6 degrees from here, we'll fly exactly parallel to the initial path. But we don't need to fly parallel. We need to turn more to reach the destination. That's why the remaining 3 degrees we add it and then we get on the track that takes us to the destination. So you may note it down and let's proceed to the next question. So let's begin with the second question. Ek paragraph ka question. But it's not going to be a headache. It's almost similar as the last question. Reason? We have the time 3 hours and ground speed 180 knots. We multiply it, we get the distance. And exactly like the last question, we will get two distances. We need to find the correction angle. So let's begin. After flying for 3 hours at the ground speed of 180 knots, an aircraft finds itself 45 nautical miles right of track. Now, if remaining time is 2 hours to reach the destination, what side the aircraft should turn and how much? So, first step, draw the diagram. Convert this distance, speed and time into distance. So the question will no more stay a headache. 3 into 180, that's 540. Again, 2 hours ground speed, again same 180 knots, multiply 18 to the 36, and that's 360. We got two distances. We have the middle S. We need to find both theta, add it up, get the correction angle. Let's begin. First of all, let's write down the formula. Theta 1, the first angle, S 45, R 540. Nine fives of 45. Got the first angle, 5 degrees. Similarly, let's find out the second one. S remains same, 45. R, now it's 360. This time we got it in decimals, no issue. We'll write it in decimals only. We can also round it off if the given options do not have decimal places. Okay, so two angles, we got 7.5 and 5 degrees. Let's put it there so it's easy to understand. Now the external angle, sum of two interior angles, 7.5 plus 5, that gives us 12.5. And also, which side should the aircraft turn? Currently we are facing this. We are facing almost southeast. We need to change our heading. We need to turn left. I hope it's easy to understand. We are facing here. Our destination is that side. We need to turn left to reach the destination. That's why the answer will have how much? 12.5 degrees to the left side. And now we are done with the second question. Please note it down. So till now we have covered one of the most common types of question and complex type of question that could come in exam. If you have any new question from that topic, you could message me on WhatsApp, email me, or ask in the comments too. But there is one more thing that they could do in exam that is still new to us. That's gradient. Till now we were dealing with angles in degrees, like 3 degree, 5 degree, 9 degree. But what if they give a gradient? What is a gradient? It is the ratio of vertical to horizontal distance written as a percentage, so multiplied by 100. And it is possible that instead of theta, they give you a gradient. Instead of theta in degrees, you get a gradient. And then how will you solve the question? So using this formula, you can do it. Let's quickly take an example. We saw earlier in the beginning of the video that if we are following a 3-degree glide path, we are 10 nautical mile away from the VOR. What is our altitude? So in that time, using theta equals to S by R into 60, we found out 3040 feet. But what if we were supposed to calculate the gradient? Let's put this value in this formula and calculate the gradient. So this time gradient equals to vertical distance 3040 feet. Horizontal distance, should we write 10 nautical miles? No, because this unit is in feet. Let's convert 10 nautical mile into feet and then write it down, else we'll have an error. So 1 nautical mile, 6080 feet, add a 0, that's 60800 feet into 100. It equals to 5%. The gradient of the same glide path, which was 3 degree, could also be written as 5%. So take care of the gradient thing. If in the question it is replaced, instead of degrees you get the gradients. That's all for this video. We'll cover the next topic in the next video. See you. Jai Hind.